In this video, we're going to discuss the distinction between one-tailed and two-tailed hypothesis tests. There are two different variants of tests. There are two-tailed test and one-tailed test. Let's talk about the two-tailed test first. The general form of this is to test the null hypothesis, which in a sense is the default condition, which specifies what may be true, which in this case is beta j equals some constant. The alternative to that is that beta j is not equal to that constant. For these hypothesis tests to work, these two hypotheses must be mutually exclusive and collectively exhaustive. In other words, they have to cover all possible cases. So in this case, either beta j is C or beta j is not C. Together, those represent all the possible outcomes. In the most typical form, though, we're testing whether beta j equals a value of C that equals 0. We use this most often when we're testing a slope parameter. For example, we hypothesize that there's a relationship between two variables, then we would expect the slope relationship to be something other than 0. Because if we say y equals beta 0 plus beta 1x and beta 1 equals 0, that's saying that x is not affecting y. Now, the general rule when we formulate hypothesis tests is if we think something happens, we start by specifying the null hypothesis as the opposite. In other words, if we think that there's some sort of an effect, we start by assuming there is no effect. And then the burden of proof is on the researcher to be able to try to provide compelling evidence to reject that effect. This is something you're probably familiar with, say, when they're testing new drugs. You start by assuming the new drug has no effect, and then you try to determine if there's sufficient evidence to convince you that there is, in fact, an effect, whether you can reject the null hypothesis of no effect. It's called a two-tailed test because you can reject the hypothesis if you're either substantively above whatever value you specified, or if you're substantially below that. So you'd reject the null hypothesis in the second example there if you get something that's substantially greater than 0 or less than 0. Very shortly, we'll be replacing substantively with statistically significant difference, but we'll come back to that. For now, let's just note there's two ways this condition could be violated. You could either be above or below the hypothesized value. That's why it's called a two-tailed test. You can reject it in either direction. The alternative to a two-tailed test is a one-tailed test, and there's two variants here. On the case on the left, we're saying for the null hypothesis that beta j is less than or equal to some constant C, versus the alternative that beta j is greater than C. At least one of them must be true, but no more than one can be true. And the hypothesis tests on the right look very similar, except we're reversing the direction. So in the null hypothesis, on the example on the right of the screen, we start by assuming that beta j is greater than or equal to C, versus a null hypothesis that it's less than C. The most common form of this, again, involves a comparison not to some arbitrary constant, but to 0. So in the situation on the left, the null hypothesis is that beta j is less than or equal to 0. In other words, it's non-positive. If you can reject the null hypothesis, that provides evidence that there's a significantly positive impact of that variable. So if you can reject the null hypothesis on the leftmost condition on the bottom of the screen here, that would indicate that beta j is significantly positive. And we'll talk about what it means to be significant shortly. On the right, we start by assuming it's greater than or equal to 0 or non-negative. And if you can reject that, that would provide evidence that it's negative. In the case of a one-tailed test, you can only reject the null hypothesis on one side of the distribution. In theory, you should use a two-tailed test if economic theory doesn't predict the sign of the parameter that you're trying to estimate. A one-tailed test is appropriate if economic theory predicts a sign. In practice, econometricians, when reporting the results, tend to report the results of two-tailed tests, even if there are some a priori predictions concerning the sign. The reason for that is that once you estimate the equation and you observe the sign, choosing a one-tailed test gives you a somewhat less stringent test criteria, making it easier to find statistically significant results. So to avoid any temptation to do that, econometricians tend to generally just report a two-tailed test result.